Good morning, students. In the last lecture, I have explained experimental study of photoelectric effect. So today I will discuss the rest part of experimental study of photoelectric effect. So first you see this is also known as laws of photoelectric effect. First, effect of intensity of light on photocurrent. First point, effect of intensity of light on photocurrent. If we plot the graph between photocurrent and intensity of light, this is intensity of light, this is photocurrent. So effect of intensity of light on photocurrent vary linearly with intensity of light. Photocurrent vary linearly with intensity of light, or that is number of photoelectrons emitted per second is directly proportional to intensity of light. It means number of photoelectrons emitted from metal surface, it depends on the intensity of light. When the intensity of light is more, now the number of electrons emitted from metal surface will be more. So when you plot the graph and the photocurrent depends on the number of electrons, so here we will draw the graph between photocurrent and intensity of light. So photocurrent, number of electrons emitted per second, directly proportional to intensity of light, and photocurrent also depends on the number of photoelectrons. So photocurrent directly proportional to intensity of light. When we plot the graph between photocurrent and intensity of light, the nature of graph will be a straight line. This straight line shows that number of photoelectrons depends on the intensity of light, and photocurrent depends on the number of electrons. So this photocurrent directly proportional to intensity of light. So here if we draw the graph between photocurrent and intensity of light, so the nature of graph will be a straight line. Clear? Now the second point, effect of potential on photoelectric current. Effect of potential on photoelectric current. Second point, effect of potential on photoelectric current, effect of potential on photoelectric current first we plot the graph between intensity and collector plate. This is collector plate potential. This is retarding potential, that is negative value. This is intensity. When you plot the graph intensity versus potential, so the nature of graph will be this is I1, I2 and this is I3. This is intensity, this is retarding potential, this is collector plate potential. So from this graph, first point, on increasing the positive potential, on increasing the positive potential increases until all the electrons reaches to the collector plate, If we further increase the collector potential, the positive potential, the value of photocurrent attains the saturation position or remain constant. If we further increase the positive potential, if we further increase the positive potential, the photocurrent become constant or attain the saturation position attain the saturation position. Now third point, if we apply the negative potential or negative voltage, the photocurrent starts decreasing, but at the certain negative potential, the photocurrent becomes zero. If we apply from this graph, if we apply the negative voltage, the photocurrent starts decreasing, and at a certain value of negative voltage, the photocurrent becomes zero. If we apply negative voltage, the photocurrent starts decreasing, but at certain negative value of voltage, at certain negative voltage, this photocurrent becomes zero. Photocurrent becomes zero. So see the graph. This is collector plate potential, this is positive potential, this is retarding potential, that is negative potential, this is intensity. So from this line it is clear that if we apply negative voltage on this side, when we move on this side, if we apply the negative voltage, the photocurrent starts decreasing, this photocurrent starts decreasing, and at a certain negative value, at a certain negative voltage, this is certain negative voltage, the photocurrent becomes zero. This negative voltage is known as the stopping potential. So see the stopping potential. What is the stopping potential? The minimum negative potential given to the collector plate when photocurrent becomes zero is called the stopping potential. So this is called the negative potential, the minimum negative potential given to the stopping potential. What is the stopping potential? Stopping potential. This is called the stopping potential. At this potential, photocurrent becomes zero. So the minimum negative potential, the minimum negative potential given to the collector plate given to the collector plate at which photocurrent becomes zero is called stopping potential. Stopping potential. If V naught be the stopping potential, then maximum kinetic energy. If V naught be the stopping potential, then maximum kinetic energy if V naught be the stopping potential, then the maximum kinetic energy, maximum kinetic energy of emitted electrons is K maximum is equal to EV naught. First you can write down this is directly proportional to stopping potential, or K maximum is equal to EV naught. E be the charge of an electron, V naught be the stopping potential, and K maximum, this is maximum kinetic energy, where K maximum equal to maximum kinetic energy of emitted electron, maximum kinetic energy of emitted electrons E with the charge of an electron, E with the charge of an electron, E with the charge of an electron, charge of an electron, V naught with the stopping potential, V naught stopping potential, this is negative potential at the collector plate, or retarding potential, it is stopping potential. At this stopping potential, the photocurrent becomes zero. Now the third law, effect of frequency of incident radiation on stopping potential. Third law, third, effect of frequency of incident radiation frequency of incident radiation on stopping potential, So here first we plot the graph between photoelectric current and collector plate potential. This is photoelectric current, and this is collector potential. On this side this is positive collector potential and this is negative. This negative collector potential is known as retarding potential or stopping potential. So if we plot the graph, this is minus V naught 1, minus V naught 2, and this is minus V naught 3. This is collector plate potential, this is collector plate potential, and this is retarding potential on this side. This is retarding potential, that is negative potential, or we can say stopping potential. This is saturation current. Saturation current means steady position. This is frequency nu1, nu2, nu3. So nu3 greater than nu2 greater than nu1. So first you see the graph. Here we are plotting the graph between photoelectric current and collector plate potential. So at the different value of stopping potential, the photocurrent attains the saturation position for incident radiation of different frequencies nu1, nu2 and nu3. So from this graph it is clear that this is the first point, the different value of stopping potential, the different value of value of stopping potential, the different value of stopping potential, different value means minus V01, V02, V03, but the value of photocurrent is the saturation position or steady position for the incident radiation of frequency nu1, nu2, nu3. So the different value of stopping potential, but the same value of saturation current, the same value of saturation current for incident radiation, of frequency of different frequency, radiation of different frequencies nu1, nu2 and nu3. So from this graph, this is the different stopping potential, that is at minus V01, this is negative potential or stopping potential, and it is also known as retarding potential. At minus V01 stopping potential, the value of current, this is the saturation position at the frequency nu1, and further increase the negative potential, that is minus V02. At minus V02, the value of photocurrent also saturation position at the frequency nu2. Here frequency will be changed, but saturation current remain constant. And when we further increase the minus V03, then the value of photocurrent attain the saturation position and frequency is nu3. Now the second point, the maximum kinetic energy of electron or the kinetic energy of electron depends on the frequency. Second point, the kinetic energy of electron depends on the frequency of incident radiation. The kinetic energy of emitted electrons depends on the frequency of incident radiation. It means maximum kinetic energy of electron depends on the frequency of radiation, does not depends on the intensity of light, but the number of electrons emitted from the metal depends on the intensity of light, does not depends on the frequency. Third point, the stopping potential is more negative. The stopping potential is more negative than higher the value of frequency of incident radiation. This is minus V01, this is less negative, its frequency is less. This is minus V02 greater than this stopping potential, frequency will be increased, and when the stopping potential is more negative, then frequency of incident radiation will be higher. Next point, when the stopping potential is more negative, then the incident radiation of frequency is higher, then higher the value, higher the frequency of incident radiation. The again next point, the stopping potential are in the order of V03 in magnitude. If you find the magnitude of this negative stopping potential, so in magnitude V03 greater than V02 greater than V02 V01 corresponding to frequency nu3 greater than nu2 greater than nu1. So from this graph, the stopping potential are in the order of the stopping potential are in the order of V03 greater than V02 greater than V01. V03, V02, V01 means this is the magnitude of negative potential of V03, V02, V01. That is, if you find the magnitude of this negative potential, so V03 greater than V02 greater than V01, if the frequency of are in the range, if the frequency of incident radiation are in the order of nu3 greater than nu2 greater than nu1. So from this graph it is clear that greater is the value of frequency, greater will be the maximum kinetic energy of photoelectrons. From this graph it is clear that from this graph it is clear that the frequency is more, then higher the value of maximum kinetic energy of emitted electrons. Now the next topic, Einstein photoelectric effect. Einstein photoelectric. I hope you understood the topic. Thank you.